Welcome to Lesson 8-2, Writing Numbers in Scientific and Standard Notation and then Using Scientific Notation. Scientific notation is a number in scientific notation is written as a product of two factors in the form a times 10 to the n, where n is an integer. Okay, so the exponent is an integer, positive or negative, and then a is always 1 or greater than 1 or equal to 1, as well as less than 10. Okay, we're going to talk about that here in a second. Examples would be 3.4 times 10 to the 6th, 5.43 times 10 to the 13, and 2.1 times 10 to the negative 10. This is the one opportunity you have to leave negative exponents. Standard form or scientific notation is the one time when we will have negative exponents and we don't have to really do anything with them. Scientific notation, why we use scientific notation, is used to write usually really large numbers or really small numbers in a more manageable way than having a ton of zeros. What happens when you have very large numbers, and we all do this, we look at the numbers and we count the zeros, or we count how many place values there are to kind of give us an idea of how big the number actually is. Scientific notation does that for us. So let's look at a couple examples here. We have three numbers: 0.46 times 10 to the 4th, 3.25 times 10 to the negative 2, and 13.2 times 10 to the 6th. Now, which of these numbers is in scientific notation and which is not? If you look at A is not in scientific notation because our rule up here says that A has to be greater than or equal to 1 or less than or equal to 1. Okay, and you can see here A, the number that's multiplied by 10 to a power, is not greater than 1. So we would have to convert that, or we could have the potential to move that decimal so that we could write it in proper scientific notation. But for this problem here, there is, you need one non-zero number in front of the decimal place in order for it to be in proper scientific notation. The second one here actually is in proper scientific notation. You've got one whole number that's greater than 1 in front of the decimal, and you're multiplying by 10 to a power that is an integer. And then the, here is a 4.6 times 10 to the 3rd is how we would write A in proper scientific notation. B is in proper scientific notation, and then C is not, because in this case we have a number that is greater than 10 in our A spot here. So we would have to make that a 1.3 and convert and then change our exponent here. I'm going to show you how to do that. So by just looking at these again, you need one non-zero number in front of the decimal. This one is, and then you have two non-zero numbers in front of the decimal here. So therefore, A and C are not in scientific notation. All right, so here's our first example. We have 234 million. Okay, to write this in scientific notation, what you're going to do is think about, you are going to move your cursor from here all the way over to between the 2 and the 3. That will give us one non-zero number in front of the decimal, so it'd be 2.34. But we have to, because we now have the number 2.34, we have to show the power of that 2.34. And we can count our decimal places. So we've moved from here to here. So how many places to the left have we moved it? 1, 2, 3, 4, 5, 6, 7, 8. And that's where we get our power of 8. If you were to try to type this into your TI-84 Plus and just type in the number and hit enter, it would not give you that number in scientific notation. But if you type it in scientific notation, so we're going to take 2.3 times 10 to the power of 8 and press enter, it will give you the 234 million. So you can use your calculator to go back and forth a little bit with scientific notation. There is a way to program your calculator to give you all numbers in scientific notation, but we probably don't want to get ourselves stuck into something that we can't get out of. So moving on to the next example. All right, let's look at example B. Now, we now have a very small number. So think about where our decimal place is and where we want to move it. Remember, we need that one non-zero number in front of the decimal. So we're going to move the decimal place between the 6 and the 3. So how many spaces did we move it? 1, 2, 3, 4, 5. Now in this case, we're making a very small number look a little bit bigger by placing the 6.3. So our exponent is actually a negative here. So we've got 6.3 times 10 to the negative 5 because we've moved our decimal place to the right 5 spots. So when we move our decimal place to the right, it's a negative exponent, and just as we saw in example A, when we move it to the left, it's a positive exponent. Go ahead and try the next 3 questions in the quick check. When you think you've got an answer, press start and check your work. We're looking at quick check 1. We have these 3 numbers, and A is written in proper scientific notation, but B is not because we have 2 non-zero numbers in front of the decimal, and there should only be 1. So in order to make it proper, we should move the decimal from here to here, and we now have 5.2 times 10 to the 4th. This is a typo here. There we go. And we now have 5.2 times 10 because we moved the decimal place 1 more spot to the left. We're going to add an extra power to our 10. In this case here in C, we do not have a non-zero number in front of the decimal place, so we need to move this 2 spots to the right. And so we're going to subtract 2 more from negative 5 to get negative 7 here. So now both of these are in proper scientific notation. All right, let's try the reverse. We're writing a number in standard notation once we're given a scientific notation number. So we have 8.8 times 10 to the 4th kilograms. Very, very large mass, the mass of an elephant. So think about, we have 10 to the 4th. 10 to the 4th is actually a 1 with 4 zeros. Okay, so 10,000. So if we were to take 10,000 and multiply it by 8.8, we get 88,000. And again, you can use your calculator to kind of check a lot of these by going back and forth. Depending on how you have your calculator set, it will show you so many decimal places on the screen, and then it will automatically, after so many place values, it will just automatically kick into scientific notation. All right, so we have a smaller value here. We have an ant's mass, okay, and it's 7.3 times 10 to the negative 5 kilograms, so it's very, very small compared to the elephant's mass. So in this case, we have 10 to the negative 5, which is a decimal that is 0.000073. Okay, now I only said 0.0, and there's 4 zeros there between the 7 and the 3, because if I were moving this decimal place to the left, the 7 would take up 1 spot, and then moving forward. So we get 0.000073. Go ahead and try the quick checks. When you're finished, check your answers, and please make sure you're writing down any questions you may have as you go. So here are our first 2 numbers. We've got 267,000. So if you think about it, our decimal place is over here, and we need to move it between the 2 and the 6. So we've moved it 1, 2, 3, 4, 5 spaces to the left, which means we're going to have 2.67 times 10 to the 5th. Over here, we need to move it 7 spots. And so, where did it go? We have 2.6 times 10 to the 5 and 4.6205 times 10 to the 7. Any zeros you can drop off the end. That's why we write things in scientific notation, so we can drop those zeros. But unfortunately, unless you're told to round something, you want to make sure that you leave all non-zero numbers attached to the end. 2 more examples. Here we've got some small numbers. So here's our decimal. We need it to be between the 3 and the 2. So we're moving it 1, 2, 3, 4, 5. 5 spots, and again we moved it to the right, so that's going to be negative. Over here we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So we have 3.25 times 10 to the negative 5 and 9.9 times 10 to the negative 9. Now we're going to be writing some numbers in standard form. 3.2 times 10 to the 12. Okay, remember this is a 1 with 12 zeros. Multiply that by 3.2 and we get, I don't even want to attempt to say that number, but you can check by counting your zeros here. We've got 11 zeros and a 3 and a 2. Over here we're going to multiply 5.07 times 10 to the 4th. 10 to the 4th is 10,000, so we have 50,700. 2 smaller examples here, 5.6 times 10 to the negative 4 and 8.3 times 10 to the negative 2. And again, we're going to make these numbers look even smaller than they are. And we've moved it 1, 2, 3, 4. And here we've moved it 2. Moving on to the next example, we are now arranging numbers from least to greatest. So the first thing you want to do when you have a bunch of numbers, and some of them are in scientific notation and some of them aren't, is you want to make them all in proper scientific notation. So in this case here, we have to move the decimal between the 6 and the 3, and we've moved it 3 spaces to the right, which means we are going to subtract 3 more exponents here. So this is actually going to become 10 to the 2. This case, this number here is written in proper scientific notation. This one isn't written in scientific notation at all, so we're going to make this 6.103 times 10 to the 3rd. And then here we need to move it 1 place to the left, and we need to add an exponent here. So these are the 3 numbers in proper scientific notation, and it looks like I've already arranged them in the proper order for you. So your first step is to write each of the numbers in proper scientific notation. And then, no I didn't. I'm sorry. Okay, then your second step is to order them by powers of 10 from smallest to greatest. Obviously, something to the power of 10 to the power of 2 is going to be smaller than something times 10 to the power of 3, and so on. And now we have these 2 numbers here that have the same power. So which one is bigger than the other? Well, then you have to look at the numbers here. 6.03 is smaller than 6.31. So we have to make sure that we put the 6.03 in order before the 6.31 times 10 to the 4th. And then your final step would be to convert those back into their original numbers so that you could write them in order. Multiplying numbers in scientific notation. We have 6 times the parenthesis, 8 times 10 to the negative 4. Okay, so what we can do here is kind of use, we can take the 6 times the 8 and we get the 48 and then multiply it by 10 to the negative 4. So we get 48 times 10 to the negative 4. Now I know the answer isn't written in proper scientific notation at this moment, but you can see here how we have basically 3 numbers multiplied together. 6 times 8 times 10 to the negative 4. So order of operations really doesn't matter here because we're just multiplying 3 numbers. So we can take and multiply these two together and then multiply it by this power